Yeah. So it's great to be with you. I'm going to start out by sharing a story about how the community I participate in got involved and why I care about this. So a long time ago, in 1999, a group of environmental organizations got together and they said, how can we use the internet to support the causes we all believe in? We care in different pieces of the environment. Some of us are focused on oceans or rivers or forests, pollution, etc. And we all have different constituencies. But this new thing called the internet has just showed up, and it's growing really fast, and we see a lot of potential in using it to make change together. And the answer they came out of from that meeting was this choice. We can build a platform and everybody joins it, and therefore we lose autonomy as different organizations, but all of our members will now collaborate, maybe, or we can stay isolated. These were not good choices, and they convened a conference in the year 2000 called Global Ecology and Information Technology, and out of that conference, there was a 18-month-long series of conversations to ask how they could solve this problem. At the time, you had Microsoft putting forward Passport, and the Liberty Alliance is a kind of like alternative, like will be other big corporations helping you manage your identity. And there's also sort of talk of like maybe the government would be providing identities for us to use digitally. Again, none of these sound like good options. So this community thought and worked together, and this was the result, a paper called the Augmented Social Network, Building Identity and Trust into the Next Generation Internet. And they painted this vision. Underlying this report is the assumption that every individual ought to have the right to control his or her online identity. You should be able to decide what information about yourself is collected as part of your digital profile, and of that information, who has access to different aspects of it. Certainly, you should be able to read the complete contents of your own digital profile at any time. An online identity should be maintained as a capability that gives the user many forms of control. Without flexible access to control, trust in the system of federated networked identity will be minimal. A digital profile is not treated by the corporations who host them as a formal extension of the person it represents. But if this critical data about you is not owned by you, what right do you have to manage its use? A civil society approach to persistent identity is a cornerstone of the Augmented Social Network project. This was written in 2003. This is before Facebook was ever founded. They're like, hey, people need to own their own digital identities. Because if they have organizations having identities and people having autonomous digital identities, then they can network together. And we solve the problem of either staying isolated or merging all into one big platform, but have a mesh network, a bipartite network of both individuals and organizations. It was around this time that I started getting involved in this community and really understood the power and potential of this vision, and I've been working for the last 15 years on trying to support the technical communities innovating what's needed to make it really happen. And so, in 2005, as was mentioned in the introduction, I founded the Internet Identity Workshop, and we've been gathering every 6 months since then to work on different protocols that we believe may have the potential to solve this problem. On that side, you can see all of the protocols you've probably heard of, and there's a new batch. And these are the protocols for self-sovereign identity. But first, why do protocols matter, and why does infrastructure matter? It matters because it shapes the future, and it has long-lasting effects. This is a map of Roman roads, and we can still see them in Britain today. They shaped where the freeways were laid down later, and the railways got built, right? And the railways built across North America also shaped something else. They shaped our time. So before this, when the first railroads were built, every city had different time, which is madness, right? Imagine, like you're going 10 miles down and it's like a different time zone. So that's where actually standardized time comes from. And it's a piece of infrastructure we take for granted that helps our whole world run. Communications infrastructure was built along these railroad lines. This is a telegraph, the device that sends the telegraph. These are the lines that were built across Europe and then across the whole world. And the standards to support the communication across these wires was innovated and organized by the International Telecommunications Union, founded in 1865. So standards are critical to helping a huge swath of what we take for granted in the modern world run, and they shape our reality. Another form of infrastructure is a physical packet known as a container. It's both freeing and constraining. If you can fit something in a container, you can ship it anywhere around the world, basically. If you can't, you can't. And so what we're trying to innovate is protocols for people, and we need to make sure they're really expansive and have a lot of potential and capacity to hold all that it is to be human. Protocol is a system of distributed management that facilitates peer-to-peer relationships between autonomous entities. Another example is SMTP that we use all the time to send email. Internet protocols allow for the interoperation between computers. HTML and CSS being great examples. And protocol is a language that regulates flow and directs net space, codes, and relationships, connects life forms, and it's an etiquette for autonomous agents. All of these quotes are from a book by Alexander Galway called Protocol: How Control Exists After Decentralization. And so there's this whole movement around decentralizing, but if we don't actually find common protocols so the decentralized autonomous agents can talk to each other, we're just building like separate like black hole vacuums that can't do anything. So this is really, really critical. So where is layer 8? And that's what we're working on, is this layer of identity, another layer on top of the existing internet for people. And what are these protocols? So let's lay out where we are today, which is we've been for, since the consumer web showed up, which is we log into websites and we get a new username and password everywhere we go. It kind of drives us batty. And we're like, why can't we take that identity with us? Partly because we didn't build this identity layer. So this is what this looks like from an architectural perspective. For every organization, you're you, a little you, with your different username and password. You've got all these different accounts. Back then, we had Friendster and 6 Degrees, and now we have GAFA, right? And in fact, the whole thing shifted again, where these companies are intermediating our interactions with other entities, right? So all of those login with Google, Facebook, LinkedIn, Twitter, they're now sitting in that middle role as the identity provider in between you and the organizations you're connecting to. And we have another option of how we control our own digital identity, which isn't super great. I can rent a URL. I can put all my stuff there. It's a good option for people who want to host their own website, but it's not meant to host me and my identity data. That's not what it was designed for, and it's not a solution for everyone to own their own digital identity. The other option is I can rent a phone number. We don't own our phone numbers. If we stop paying our telephone bill, it reverts back to the phone system, but how much stuff is linked to your phone number now? And there was attempts in our community several times to build a global namespace specifically for people, and all of these attempts had failed, so I don't recommend trying it again. So where are we? This is where we start the talking about the self-sovereign identity technology. So there's a new standard called Decentralized Identifier. And it's a way that individuals on their own wallets can create an identifier that they generated. No one gave them authority to do it. No one issued them a number. They created on their own from their own wallet. And it comes with 2 parts. It comes with a public key and a private key, right? And you put your private key in a wallet, of course, and you keep it safe. But now what? We've got a really long number, a decentralized identifier. What does that get us? We need a little bit more standardized infrastructure to go with it, some protocols. So the next piece is a DID document. And DID document is a JSON LD document describing the entity identified by the DID. And I'm going to go through the simple pieces of the DID document. So there is a DID. The DID is in the DID document. It's self-describing. There is a set of keys, public keys for verification, a set of authentication protocols to support authenticating and proving that you own the DID, and then a set of service endpoints for interactions. Where is your personal health data? You can point at it using this protocol and support your healthcare providers finding it in a common location. You could store your resume. This is the addressing system for how you get the data, right? A timestamp for audit history, and then a signature. So where do we put these things? So we have a really long number and this very simple document that goes with it to support interactions. And right now there's 2 ledgers that are specifically focused just on identity, and then you have Uport that's on top of Ethereum. So you have the sovereign ledger, which is using Hyperledger Indy code, and you have the Verus 1 ledger. Both of them were specifically designed just to store DIDs and DID documents, and they have a vision of being global public utilities where anybody can post their DID and then have it be resolvable. So this is how we can create addressable identifiers that are created and owned by people, because really long numbers by themselves aren't interesting. You need to find them, which is why ledgers are interesting, because they're immutable, they don't go away, at least if you're putting them in a stable long-term resource ledger. And you can also, you can update them, right? It's like, so if I have control of my private keys and I want to rotate my keys, I simply post to the ledger again and say, my keys rotated, right? So how are normal people going to use this? So we have cell phones and we have personal clouds, storage that we own and control. And so this is how it looks from another perspective of individual identity owners having edge wallets on their phones and mobile devices, connecting up to cloud wallets and agents, and then those are posting their DIDs and enabling the connection using the ledger. So it's really critical. No personally identifiable information is stored in ledgers. It's just these really long numbers and their public keys. And this is really critical for privacy, right? And so this is a whole stack. And it's in this cloud layer right here where you have peer-to-peer encrypted communication, right? So there are different ledgers in the emerging ecosystem, and they have different methods. So each DID method specification defines how to read and write a DID and its DID document on a specific blockchain or distributed network. And right now, here's a collection of the DID methods that are active. You can find this listing up on the W3C website. And there's more being added any day. So Pillar, for example, could create its own DID method and post it here. Hopefully, we will have a not an infinite number of DID methods, but a certain number that enable different services, different networks to have differences that are worthwhile having, but not a huge number. So the DID method specifies the syntax, method-specific elements of a DID document, and how to create, read, update, and delete operations using a DID and DID documents in the target system. So really long numbers aren't interesting by themselves. They don't tell us much about people. So verifiable credentials is a critical standard that goes with this. I'm going to walk through it. So what do we mean by a credential? So a driver's license is a credential, a certificate you graduated from colleges, a license to do something. But you could also think of micro-credentials, like I went to one yoga class, right? It doesn't have to be like these big things, right? It could be like I attended the Pillar Conference for a day. I got a little micro-credential, yeah, right? Like, as soon as somebody started talking about micro-credentials, I was like, oh my gosh, we could do so many things with this, right? Because it's a tool to start communication and sharing and proving little things about yourself so you can connect up with other people in different settings. So this is how they define it, that verifiable credentials express credentials on the web in a way that is cryptographically secure, privacy respecting, and automatically verifiable. So this is the anatomy of a verifiable credential. It has these parts. It has the credential identifier. There's metadata in the credential. There are a set of claims in the credential, along with an issuer signature, right? And so this is drawing the analogy between the physical version of these types of things and what the digital version has. Okay, this is a big problem that verifiable credentials solve. How do you know it's true without phoning home? How do you know that I am a licensed driver in the state of California and a graduate of UC Berkeley? Well, one way is you believe the physical documents I present to you, but now we're just presenting digital documents. Okay, how do I know they're true? Without calling up the uni and saying, did she really graduate? Hey, state of California, is she really over 18? Now, this is really critical because it's not super privacy invading if an employer calls up your uni. It sort of makes sense. But you do not want the state to see everywhere you use your digital driver's license to prove attributes about yourself. That's super privacy invading. So we need to figure out how people who are looking at your credentials can believe your credentials without asking the state if they're true. And this is what the distributed ledgers solve. So you have an issuer, a government, an employer, et cetera, a holder, the individual has their wallet, and a verifier, which is where you present the credential, right? And this is another, this is the same drawing, but drawn slightly differently. We have the issuer who issues the claim or credential to the person in their wallet, and the verifier who looks at it. And the thing that means you can believe it is because when the issuer issued it, they put their signature and a did in ledger, and the person countersigned it. And so when they present the credential, that's there, and the verifier can believe it by looking at the registry, looking at the ledger, not by talking directly to the issuer. Right? And this is this breakthrough that we've been looking for a long time, which is like, how do you really support people sharing these types of things without causing a giant privacy problem? So this is back to the different version of the same diagram. You have the issuer publishing to, using a DID to the decentralized distributed ledger, the holder, and the verifier. So it creates the capacity for the individual to have a peer relationship with the institutions they're interacting with. They are no longer just, they're coming with their own claims, their own credentials, and their own identifier. They're a peer. They're not underneath the website, and they're not subject to the terms and conditions of identifier issuers. They're the owners of their own identifiers, and therefore they have the capacity using new software tools to own their own identity. So with self-sovereign identity, we potentially end Facebook, we end phone numbers, and we end email providers because we can use this infrastructure to talk to each other, to network in groups. It's not that there won't be any software providers, but fundamentally, when we own our identifiers, the architecture shifts, right? There's no personally identifiable information on the blockchain. I'm going to highlight this point about the thing is that they're directed identifiers. You do not have one DID. You have potentially thousands, and you're capable of keeping different aspects of your life separate because for every individual you connect with and every institution, you get new identifiers. And you manage that all with a wallet. This is impossible without digital tools that act on your behalf. So this is a very interesting use case. It's very real and happening that I wanted to share with you all because it's sort of like, that's all nice, but like what's really happening? So the British Columbia government is building a verifiable organizations network to issue self-sovereign verifiable credentials to businesses in the province. So it turns out that the province is responsible for a whole bunch of claims or credentials that businesses need. They charter themselves by filing paperwork with the province, they get business license, they get a liquor license, a whole range of different types of licenses, all by different departments in the province. So this is an example about starting a restaurant. These are all the different types of permitting and licenses that a business would need. And so what they did is they took all of these different licenses, and because business information is already public, right? It's in public record. They have the ability to pull it together and display it because they do it anyways in their existing set of databases, right? And they built a giant, what they called the org book of all the different claims of all the businesses in the province. So you could look up different businesses and figure out what licenses they have. And then they can issue these to the business owner in a digitally native form and in a digital wallet, right? So this is what it looks like. You have the British Columbia issuing the claims to the business owner, and then they even have a counterparty, which is the government of Canada. So in order to get a contract selling things to the federal government, if you're from British Columbia, they're going to insist that you get a verifiable credential that says you're chartered by the province. So I wanted to just touch on this. There's a whole set of emerging standards around how to do data sharing with verifiable credentials and decentralized identifier. There's object capabilities, there's XRI, XDI, an emerging protocol called JLink, and user-managed access. I did not have time to go into all of those today, but there's a whole set of work being done, not just on the identifier part, but how do we put with it data and support individuals sharing those. You've got the Decentralized Identity Foundation. A lot of groups are involved, most notably Microsoft and IBM. And they're working on DID-Auth as one of their projects, which is a simple standard way for a DID owner to authenticate that they are the owner of a DID by proving control of a private key. They're also building a universal resolver. As we saw in the presentation, there's more than one ledger. And so if I present a DID to a verifier, they need to be able to go find it in whatever the ledger is. So instead of having everybody build their own, they're like, okay, we're going to figure out how to do a universal resolver. And there are some differences between the ledgers. You have Ethereum and Verus1 and permissionless and public, and Sovereign is permissioned and public. And this is more about who can run the nodes on the network, more than the data in the network. They have different speeds, and there's different costs to creating a DID, right? So Bitcoin is, you can post and make a DID, but it's kind of expensive to do it. Ethereum, also expensive. Verus1 is doing a per DID pricing model with agencies that have write permissions. And Sovereign is doing an ICO, and so it's not totally clear what the price will be. So these are the three main ledger projects. And with that, I just wanted to share this diagram one more time and say, now we can do this. We can have organizations with digitally native credentials that they own and control, and individuals, and we can network all of us together in new and really exciting ways that hopefully will empower us and our communities going forward. So this is where you can find me. I'm at identitywoman.net. I have a report coming out in the next week or so for C-level executives, specifically focused on self-sovereign identity and understanding in detail this emerging landscape. I invite you all to participate with us at the Internet Identity Workshop, either in October or in April, May. And I have one last project, Human First Tech, looking at how we really center humans and communities that haven't necessarily been involved in creating technology before and making sure in this new layer that they're actively included and involved in making this happen. So thank you so much.